We are given this problem, and we need to find the value of x. As soon as we see these types of problems, the very first thing that comes to mind is to eliminate the square root by squaring both sides of the equation. But look carefully. The right side already contains a square. So, if we go ahead and square both sides directly, we will end up with a quartic, or a degree 4 equation like this, which is super hard to solve. That's why it's worth pausing and thinking. Is there a smarter way to approach this? The answer is yes. This is what separates a clever problem solver from someone who just follows steps blindly. First, let's establish the necessary conditions for the equation to be valid. The term inside the square root must be non-negative, and thus 5 minus x must be greater than or equal to 0, or x must be less than or equal to 5. Next, since the left side is a square root and is always non-negative, thus the right side must also be non-negative, and therefore 5 minus x squared must be greater than or equal to 0. This means x squared must be less than or equal to 5. Combining both of them implies x must be between minus square root of 5 and square root of 5. Great. Now let us assume a variable y equals square root of 5 minus x. From this definition, we can square both sides to get y squared equals 5 minus x. Now, substitute y back into the original equation to get y equals 5 minus x squared. This way, we have a system of two equations. Now, what to do? This seems more complicated, right? But wait, the real magic is coming. From this equation, we can express 5 as y squared plus x. And from this equation, we can express 5 as x squared plus y. Thus, we can equate both the expressions for 5 to get y squared plus x equals x squared plus y. Now first bring this y squared this side and group it with x squared to get x squared minus y squared. Then bring this x here to get x squared minus y squared minus x plus y equals 0. We can also rewrite this as minus of x minus y. Hey, from the difference of square formula, we know that this thing is simply x minus y times x plus y, isn't it? Next, we can factor out the common term x minus y from both of them to get x minus y times x plus y minus 1 equals 0. This equation implies two possible cases, either x minus y equals 0 or x equals y, and the other case is x plus y minus 1 equals 0 or x plus y equals 1. This means y equals 1 minus x. First, let us solve this case. Substitute y as root of 5 minus x to get this. Now we can square both sides to eliminate the square root and get x squared equals 5 minus x, and after rearranging this, we get this nice quadratic equation. I will not bore you by solving a quadratic equation, and thus its roots will be this and this. But this root is approximately this, and it does not satisfy the condition we have on x. Therefore, we reject it. Now consider case 2. We have y equals 1 minus x. Substitute y to get this. Then square both sides to eliminate the square root. Expand this to get 1 plus x, square minus 2, times x equals 5 minus x. After rearranging this, we get this nice quadratic equation, whose roots will be this and this. Now this root is approximately this, and again, it does not satisfy the condition we have on x. Therefore, this solution is also not valid. So we are finally left with these two values of x, which satisfy our original equation.